Okay, here we are finding the domain and range of the relation from the graph. And remember that the domain is all of your inputs, your x values, and your range is all of your outputs or your y values. When we look at the domain, we'll look at everything on the x direction. This graph is going to keep getting wider and wider in both directions. So in terms of our domain, would be everything from the left side of the graph to the right side of the graph. And that is everything from negative infinity to positive infinity. So we say the domain is all real numbers. If we want to use interval notation, we would say that the domain is all of the x values from negative infinity to positive infinity. The range is corresponds to the output or the y values. And let's look at how low and how high the graph goes in the y-axis. So this graph doesn't go all the way down to negative infinity. It looks like it stops right here as a lowest y value of -1, and the graph goes up and would continue to go up, and those arrows denote that the graph is going to continue to increase up the page. So our range is not exactly all real numbers. It actually stops right here at -1. So we can say the range is all the y values that's greater than or equal to -1, or using interval notation, starting out at -1 as your lowest value up to your highest value of infinity. Now, a vertical line test will help us determine if a relation is a function. If every vertical line intersects the graph of a relation in no more than one point, then we say the relation represents a function. So the first one for part A, we can draw a vertical line. If that vertical line goes through more than one point, we say that this is not a function because it does not pass the vertical line test. The second example in part B, no matter where we draw a vertical line, we would see that the graph would only intersect the vertical line in only one point. So we say this is a function because it passes the vertical line test. In this example, we want to use the vertical line test to determine whether each relation is a function. Well, this particular relation is the set of those 4 points. If we draw a vertical line anywhere through, we would see that it would only intersect the vertical line at only one point. So we can say, yes, this is a function because it passes the vertical line test. For this one, we would again use the vertical line test to determine if this relation is a function. If we draw a vertical line, we'll see that in some cases, you will intersect the graph in more than one point. You graph it here, it intersects at exactly one point, but we would want to test every possible vertical line, and there are many vertical lines that would cut through more than one point. So we say this is not a function because it does not pass the vertical line test. Okay, for this one, we want to determine if this relation is a function by using the vertical line test. If we graph a vertical line, no matter where we graph that vertical line, the graph would only intersect at exactly one point. So we can say, yes, this graph is a function because it passes the vertical line test. Okay, and then finally, let's use a vertical line test to determine whether this relation is a function. Where no matter where we draw a vertical line, the vertical line will only intersect this graph at exactly one point. So we can say, yes, this is a function because it passes the vertical line test. So go through and work on the homework assignments for the chapter 3. Work on the practice and be ready for the test.